Hey phono friends, Don Wilson here with a little bit of an experiment going on. Recently I tried Googling what are the groove dimensions of a diamond disc, and of course everybody knows that it's 150 lines per inch. But geez, I tell you, if I couldn't find what the width of the actual groove was, sometimes you just have to do things yourself. So what I've done here is I took a diamond disc that I had made in white and took a little magic marker, made a little red spot as you can see over there, and that way we have some nice contrast. By just gently rubbing the magic marker across the top, I was able to only color the groove walls and not inside the grooves. Going parallel with the grooves probably would have colored the grooves too, but there we have just the top of the groove walls, and a really handy little piece of technology that, if you're in the habit of looking at things that are this small, is that slide. It's called a calibration slide, and it's just a series of teeny tiny little rulers. So this particular one, see if I can find something better to point with. Oh well. This particular calibration slide, the ruler that we're using right now, it has lines that are each 1/100th of a millimeter. And here we have a big one that's at the end of the groove wall, and that line that we can see in the middle is 5/100ths, and there we have 10/100ths, that next big line. So 10/100ths, that's a tenth of a millimeter, the groove wall. And if we then go from there, there we have 5, and probably about 2 more. That's a decent guesstimate. That would give us about 7/100ths of a millimeter. The problem with looking at things that are this tiny is you can either focus on the calibration slide or you can focus on the object, but you can't really focus on both at the same time. That's why the color helps a little bit. But here, if we look at magnification, which is a few hundred times, we can see that 7/100ths of a millimeter is about right. And so that puts us at a hair under 3/1000ths of an inch with a groove wall that's a hair over 3/1000ths of an inch. So that's all I have for you for today. Thought you might find this interesting. One other thing that we can do while we're at it is if we add in ultraviolet light to try to get that bouncing off, we can accentuate that difference between groove and groove wall by getting that light to really shine in and reflect back. The different wavelengths will behave differently. And if you've got nothing else to do and want to stick around for a moment, one other thing that we can do is on this calibration slide, there is a dot which is 0.07 millimeter. Now let's see if we can get that 0.07 millimeter dot in here. I tell you, it's not easy, especially when the camera's running. We've got the dot. Trying to move these things a couple thousandths of an inch is its own challenge, isn't it? Ah, there we go. Okay. So that dot is 7/100ths of a millimeter, and you can see that it fits nicely inside that groove. So thus confirming that an Edison diamond disc does in fact have grooves. The grooves are cut to just under 3/1000ths of an inch. Doing the math, I believe it was 27/10,000ths. And we can also see that the groove wall is a bit thicker. So that would help us understand why the later long plays experienced wall degradation. Well, I hope that you found this interesting, if not helpful, and be sure to watch for the next edition.